Hi, welcome to the video for 5.6, Law of Cosines. First, I want to point out this lovely picture right here. This is what your textbook puts at the beginning of this section because they think that this photo will encourage you to learn Law of Cosines. And I don't know about you, but I look at this and I think, no, no thank you. So Law of Cosines is another law that helps us solve an oblique triangle, a triangle that does not have right angles. But in order to use law of sines, so sine of angle A over side A is equal to sine of angle B over side B is equal to sine of angle C over side C. In order to solve this, you need either two sides and an angle, right, to complete these two proportions, or you would need two angles and one side. So what if we don't have those things? What if we are given either three sides or side angle side? If one of those things happens, so three sides, that would be like these three denominators, then we wouldn't have a full proportion. And side angle side would be like A, angle B, and side C. And again, neither of those proportions would be full. So we couldn't use law of sines, we would need to use law of cosines. Now, law of cosines is going to look a little complicated, but I would say two things. The first is you get the formula sheet, so you don't necessarily have to memorize this, and it kind of follows a pattern, which I'll try and show you in a moment. So let's write out law of cosines. The first would be if I have side, angle, side. So I have two sides and their included angle. So let's start with this. A squared, side A squared, is equal to B squared plus C squared minus 2BC times cosine of angle A. And I'm not going to go through today the proof of law of cosines. If you're curious, I believe it is in your textbook, and I'm happy to go through it with you one-on-one, but it's not totally necessary, and so we're not going to do it. We can rewrite this for any three pieces, two sides and one angle, and so I'll go through those. If we have b squared, we're going to say a squared plus c squared minus 2ac times cosine of b. Notice that the side we're solving for is the angle that we are given. And last but not least, of course, we could write this if we are given side, or not given side C, but given angle C and sides A and B. So C squared is equal to A squared plus B squared minus 2AB times cosine of C. These formulas can also be rearranged so that if we are given, so this was the side angle side option, well, what if we are just given the three sides? So what if we are given side, side, side? Basically, we rearrange this for cosine of A, cosine of B, cosine of C. So cosine of A is equal to, well, think about it. If I were to rearrange this, I'd be moving the B, well, I guess one way would be to move this piece to the other side and then subtract the A squared. So B squared plus C squared minus A squared, and then divide it by the 2BC. So really it's just rearranging this left equation. And of course we can write these for all three angles. So cosine of B is equal to A squared plus C squared minus B squared all over 2AC. Or cosine of angle C is equal to A squared plus B squared minus C squared over 2AB. Notice, again, if we're looking for patterns, the angle that we are interested in is the odd one out, like the side that is being subtracted, also the side that is not included in the denominator. These these six formulas are all on your formula sheet, so please don't feel like you need to memorize these. You just need to be able to use them. There's one extremely important note that I need to say right here, and this is potentially one of the biggest things in this video because it will potentially have you get a wrong answer, and we don't want that. If you begin a problem by using law of cosines, you must end the problem also using law of cosines, meaning don't switch over into law of sines, even though law of sines I realize is the easier option. Well, why is this? I don't have a full, like a super detailed answer, but let me just show you an idea on the unit circle. So let's say I am looking for I'm given an angle. Let's say this is my angle, and I know that this is some x comma y. Sine is y, cosine is x. So what other potential angle down here has the same x? Well, this guy, but it has an opposite y. And so this is actually the angle we are trying to solve for. This is another option, but it actually isn't the one we want. If I switch over to law of sines, I'm actually going to be, so sine is y, the other value that has that same y value is over here. And this is not the angle we're looking for, right? We started here, and this is actually the angle we're interested in. And we don't want to solve for this guy over here. It also kind of has to do with inverse trig and where those live, right? We talked about inverse sine is only in these two quadrants, quadrants 1 and 4. Inverse cosine is in the top half of the unit circle, quadrants 1 and 2. So it all works with that. And realistically, the thing you need to know is that if I start with law of cosines, I have to end with law of cosines. Otherwise, you might end up finding a triangle that is not actually the one you want. Let's consider triangle ABC, which is not necessarily a right triangle. We have seen this triangle before, so if you need to pause the video and draw it, please do. But we've got sides A, B, and C across from angles A, B, and C, and then I drew in the height. Now the question is, what is the formula for the height of this? No, not for the height. For the area of this triangle. And if you remember the area of a triangle, it's 1/2 base times height. And in this case, 1/2, our base is C, and our height is H. And that's lovely, but if we think back to our last lesson, we had solved for H as B times sine of angle A, or we said it's A times, oops, why is it writing over there? A times sine of angle B. And so we can use this height to change our formula here. And what we find is an area formula for a triangle that does not need the height. So 1/2 C times, we'll start with this first one, B times sine of A. But of course, we could think of this as like, if I turned my triangle, then A would be the base. And so I could also write it as 1/2 A times B times sine of angle C. Notice I have two sides and the angle between them, right? So C and B and the angle between them, A and B and the angle between them. So of course our third option would be 1/2 A times C times sine of B. All three of these are the exact same formula, but just depending on what you have. And maybe the smarter way to write this would be 1/2 side, oops, not sine, side times sine of the included angle, the angle in between. One more area formula is known as Heron's area formula, and this is on page 445. This is another one of those, like, we're not going to go through the details of the formula because it's kind of outside the scope of what we need right now. But I will start by saying the semi-perimeter is known as S, and it's a sum of the sides divided by 2. We need that because I can find the area of a triangle by taking the square root of the semiperimeter times the semiperimeter minus side A times the semiperimeter, oops, let me make that nicer, times the semiperimeter minus side B times the semiperimeter minus side C. So this is just another formula for area. I'm going to show you the next two or three examples, and if you want to pause the video so you can write them in your notes, please do so. Otherwise, those are all the notes you need for this section. So we will look at this one in class. Pause the video right here if you would like to write it down. We will look at this in class. Pause the video right here if you would like to write it down. And we will look at this one in class. Of course, pause the video if you are interested in writing it down.